So let's do a quick review of what we've done so far. We've materialized the product. We got all of our components into the correct orientation. We've done some organization work. And we've gone through and optimized the geometry. The next step in the process is we want to create ambient shadows. Before actually creating the ambient shadows, I wanted to mention something I haven't really brought up. You'll notice I just selected the ground, and there's a special plane in here. And on that plane, there's a material called shadow. The shadow material is a special type of material that only shows the shadow. In the real world, two pieces of geometry that are near each other tend to cast a shadow upon each other. Ambient shadows is a software technique that calculates where the shadows would form, and then bake or attach the results to the surfaces. Therefore, especially in the OpenGL mode, we need to calculate the ambient shadows for the product to look realistic. Similar to normal calculations, there's a special rendering mode for ambient shadows. As I deselect the geometry, it's easy to see that everything's white. We have no ambient shadows calculated, and we're going to do that next. To calculate ambient shadows, the first thing I need to do is select the geometry. So I select the exterior and the shadow plane, and then I can start my calculations. Our controls for working with ambient shadows lie in the Properties section in the Occlusion tab. To start with, we're going to use the default configuration, and we're going to tell it to calculate all. Calculating ambient shadows is computationally intensive. I am showing this process in fast mode. On my computer, this process took about 4 minutes to complete. Now that the natural shadows have been calculated, you can see the effect that shadows have on the car. Shadows are darker in areas where the objects are inside, like in wheel wells and cutouts. The reality is that most panels in this car are affected by ambient shadows. Let's switch back to realistic rendering mode to see the difference that ambient shadows make. Here's a before and after comparison of ambient shadows and non-ambient shadows. I've switched back to the Occlusion rendering mode because I wanted to talk about the tessellation effect. If you look at the area around the headlamp, you can see a triangulated pattern. This pattern is caused in part by the way that the geometry was tessellated when brought into VRED. There is a control in the Occlusion interface called Enable Subdivisions. This tool will subdivide a surface's tessellation to give more triangles to work with. The process adds more triangles, but will often provide better occlusion characteristics. Let me jump directly to the finished result using Subdivision. The results are much smoother and realistic. Let's look into this a little bit more. We'll start by turning on the wireframe so that we can look at the surfaces in more detail. As we zoom into the corner of the windscreen, we can see that there's a whole bunch of triangles now that are right next to the edge of the body panels. This is what is creating the difference before and after subdivision. Ambient occlusion is based off from the vertex, so therefore the more vertices that are available, the better the ambient occlusion is going to look. Let me pull up an image of the same area taken before subdivision. Notice the large triangle structure on the windscreen next to the headlamp enclosure. Now in a side-by-side, you can more easily see the added rows of triangles in the same area. Now is a great time to take a picture. Our model is set up, we've got ambient shadows, it's starting to look realistic. But before we go into doing rendering, there's one more setup that I always recommend that people do. I've opened up the Render Image window, and the first thing to do is to set the image size. As I look at my render window, I really don't have a clear understanding of my viewport view. Looking into the Scene Settings tab, we can see that we are in Dynamic Resolution. I want to take a 16:9 image. So I'll choose one of the preset 16:9 settings. After it is selected, the render window switches to the 720p setting. I can then frame my model better. Back into the Render Image window, set the image size, and then click the Render button. After giving the file a name, VRED will render the image. A small window shows us our rendering progress. Now that the image is done, let's take a look at the rendering.